Okay, so this is number 27 and 9.4? Yes, good. Okay, so what do we do? Okay, yeah, we should probably write it in a kind of way we're used to, right? So first we should find the grouping symbols. So the fact that this bar is bigger than the others, right, means that really I take this stuff up here and divide it by this stuff down here. Yeah.
Should we write the TT, TB, BT, BB?
We could try that, but there's probably not a lot of simplification I can do on this one that way.
Oh.
So on this one, because everything's already kind of, right, the top's already a fraction by itself, the bottom's already a fraction by itself, I'm not going to do the labeling of the top and the bottom of the bottom, because I'll just get this thing back again. So what I would start with is write the top fraction. Divided by the bottom fraction, right? And then what? Flip the second one, right? So I make this into the first fraction. Right? Multiplied by that one flipped over. That's called a reciprocal, by the by. Okay, so I got to here. Now what?
Factor out.
Okay, I can factor some stuff out. What can I factor? What comes out of
X
these?
squared minus 7, x minus 2.
This guy?
Yeah.
Okay.
That's 17.
It should be a x minus 7 times a x minus 2. Does that work? See, I get x squared, check. 14, check. Minus 7x, minus 2x. Yep, that seems like it worked. Cool, good factoring. Yes?
17
Yeah, we can say, okay, 34 is 2 times 17, right? So on the bottom here, I can write 2 times 17 times x to the 4th. Yeah, so, okay, we could write 4 x's here, right? In the top, let's see, what do I get? There's a 17 up there.
Can you move down the computer?
Yeah. I unfortunately can't move the dot cam yet. I'll move it later.
X to the 4th and another x.
Yeah, x to the 5th is 5 x's multiplied together, right?
Yes.
So really that means it's 4 x's times 1 more.
Great.
You guys see that? So I can write it as x to the 4th times x. What can I factor out of the bottom?
5.
Factor a 5 out. What are you left with?
X
Okay, x squared minus 4, right?
X plus 5, X plus 2, X minus 2.
Close. Let's see. So what can I cancel at this stage?
17.
Okay, so I can say, all right, there's a 17 here and here. Those can cancel. What else can I cancel?
The x to the 4th.
There's an x to the 4th and an x to the 4th. Anything else? So far, that's it, right? What's up?
Why did you leave it x to the 4th and then times x instead of just writing x and then?
I could have, right?
But did you leave it like that?
I would
so
have
that way
done-
You could simplify with that?
Yeah, I would have, if I had written this as x times x times x times x, right? So really here, if I thought about this as x times x times x times x, right? That's the same thing as if I thought about this in the same way, right? That's x times x times x times x. That makes sense?
So you can just take one out and leave it as 1 to the x.
Yep. That's really using an exponent rule. Right, that's using the fact that this is x to the 1, and when I multiply x to the 4th times x to the 1, I add the exponents, I get x to the 5th. Cool? All right, so what's the next thing you should spot on this? Yeah, we should spot x squared minus 4 is not a perfect square, but a difference of squares. Okay, so I've got let's see, what was I left with on the top?
X
Minus 7.
There's a x minus 7, there's a x minus 2, and an x. And on the bottom, what am I left with?
2.
There's a 2 times a 5 times, the thing that was difference of squares, right? So that's a x plus 2 times a x minus 2. Okay, now what can I cancel? Okay, now we can cancel the x minus 2's, right? So we're left with, in the end, an x times a x minus 7 over
10 times x plus 2.
10 times x plus 2. Cool. Good? Can I simplify any further?
No.
No.